So let's go ahead and solve the equation. Tangent of 4x equals 1. So we're using SOHCAHTOA. So we want all the angles whose tangent is 1. So in the first quadrant, that would be opposite over adjacent, 1 over 1. In the second quadrant, we would get a negative 1, so we don't pick that. In the third quadrant, we would get a negative 1 over negative 1, and so that works. And if we're in the fourth quadrant, we get negative 1 for our vertical length, so that does not work. So we're just in the first and third quadrant here. So these are 1, 1, square root of 2 right triangles. So this is a 45-degree angle, or pi over 4. And then how many pi's over 4 do we go to get to this one? If we divide into 8 slices here, we see 1, 1, 2, 3, 4, 5 pi over 4. So the 4x can be pi over 4, 45 degrees, or the 4x can be 5 pi over 4, 225 degrees if you convert to degrees. So we need to find all the angles coterminal with this, because our terminal side just has to stop in one of these two positions. It can spin around the unit circle repeatedly before it stops in one of these two positions. So to account for all those infinite possible answers, we say plus 2 pi k. So let's go ahead and multiply both sides of these equations by 1/4, and then we'll have solved for the x. So we have x equals pi over 16 plus 2 pi k over 4, where x equals 5 pi over 16 plus 2 pi k over 4. So those second terms reduce. So x is pi over 16 plus 2 pi, plus pi over 2k, or 5 pi over 16 plus pi over 2k. Now notice that the pi over 16 plus 1/4 pi, that comes out to be pi over 16 plus 4/16 pi, or 5 pi over 16. So these two answers are just 1/4 pi apart. So we can describe all of these answers more succinctly if we just say x equals pi over 16 plus pi over 4 times k, and that will describe both sets of infinite answers combined into one description. So let's go ahead and take a look at finding the answers that lie between 0 and 2 pi. So let's do that on the next page. We'll write this down: pi over 16 plus pi over 4k. And then we'll let k take on the values, the integer values, until we get outside the 2 pi range. So we have k equals 0 to start, so that just gives us our pi over 16. Then we could have k equals 1, so x would be pi over 16 plus pi over 4 times 1, and we get a common denominator there. So pi over 16 plus 4 pi over 16, or 5 pi over 16. And how about when k is 2? Then we'll have x is pi over 16 plus 2 times pi over 4, and we'll multiply by 4/4 there. So x would be pi over 16 plus 8 pi over 16, or 9 pi over 16. How about when k is 3? So we would have x equal pi over 16 plus pi over 4 times 3. So that's pi over 16 plus 3 pi over 4 times 4/4. So x equals pi over 16 plus 12 pi over 16, or 13 pi over 16. Okay, and how about k equaling 4? So we have pi over 16 plus pi over 4 times 4, so 4 pi over 4, and multiplying by 4/4, we would have pi over 16 plus 16 pi over 16, so 17 pi over 16. How about if k is 5? Pi over 16 plus pi over 4 times 5, multiplied by 4/4. So we have pi over 16 plus 20 pi over 16, so 21 pi over 16. If k is 6, then we have pi over 16 plus, well, I think you're getting the hang of this. The other ones that we end up with would be 25 pi over 16 and 29 pi over 16. So I'll leave you to find those on your own.